Now, the way you calculate the distance between two actors in the 3D world is by vectors. So what we need to do for this is, let's get player character. We have it here. So let's just for now copy it. And we will get actor location. Copy this again, paste this, and here. And we are going to subtract one from another and get vector. Oh, no, we don't need vector. Get vector length. So let's, for now, print string this value. And let's put it into event tick for now. Compile, save, press play. Oh, my apologies. We need to make sure we put it into the string, not the duration. Compile, press play. So, as you can see, the lights are calculating the distance between the character and themselves. And the closest unit I can see here is like 1400. Now, what we can do is we have this value we are getting, and if this value is less than, let's say, 2500, or even let's say 2000, it is true. If this value is less than 2000 on event tick, let's do it this way. If it is true, we will have the lights follow the character. Press play. So now you see we have lights that are following us, and if we move around, the closest lights follow us instantly. And when we go out of the range, as the distance becomes now gives a boolean value of false, it's no longer following us. Obviously, we don't want it to be instantly on us. We will use a timeline for it in a moment. But for now, this is fine, as we are just testing the targeting system. Again, I am noticing we have a light here with which I tweaked values. We are going to restore this, save it, and another one here. I'm not sure why I tweaked so many values, but it is what it is. Make sure to clean up after you edit the values for testing purposes, and don't do it like me. Now, this logic works. We can get the location, distance, actor distance, to be clear, but we don't want it to be on event tick. This is fine, and what we need now is a proper follow target functionality. We are going to expand this a bit and have everything inside, and let's add some extra space so we can work. The issue we have now is when should we get this check and when we should start getting the rotation and how. We don't want to do it with the event tick as it's very performance heavy. Instead, what we can do is we can check it instead of every frame, every few seconds. And the way we can do it easily, we can do it then the sequence here. And actually prevent this timeline happening. 1 second, let's remove this pin. So we are going to get this around as well, as we are going to need it later. We have this random colors which we want always to trigger, so we are not going to touch it. But we only want this to trigger. Let's make the sequence outside. If there is no player target. So we can put a branch node here and run it through the branch. And if it is false, we are going to have this function as previously. And if it is true, we are going to drop this to the bottom section where we are going to follow the player character. Now, the way we can do this is, let me put it back into the value here instead of having two branches. It is unnecessary. And let's add a timeline. And this timeline can function in a similar manner. We are going to have a lerp. Rotator. And we are going to have our alpha set here. And find look at rotation. New rotation will be this one. And the actors relative rotation. In this case, we want the light to follow full on, not only the spotlight. As such, let's change some parameters here. We were moving the spotlight only, but with our new light, we can move the whole light itself. We are not limited to our spotlight, so let's make sure we fix this up before we move on. This relative rotation parameter is fine, but it should be just rotation, not relative. And we are going to get actors location. Actors rotation. Get rotation actor. We are going to get this actors on rotation. We are going to apply. We are going to set it, and we are going to at the very end not rotate the spotlight, as there is no real reason to only do it with spotlight. We are going to copy this again and set rotation, actor rotation, and actor itself. We get a new rotation value and we update this. Now let's try it out again. Press play. Lights are moving around as they should. Some of them remained on the spot because we had the branch node. We move around here and the lights we are closest to will not move around. But the rest of it is working as it should. Let's take into a look by using simulate and see how it lights. Yeah, they are moving around. Perfect. Okay, now we had an error, and this error in the mode because we were trying to access player character and player actor did not exist when we were simulating, which is fine. We don't really need it during simulations. And here on true, let's try it on true. This will trigger here. Our second timeline will trigger, and this timeline can be shorter. So let's make it 1 second. And the value for it can be 1 as well. We want lights to react instantly. The player being close to show him to shower him in light. And we have this lerp node, which is now calculating the actor's location and target's location, and we are setting our target as a player character, which is what we are going to do. So if vector length between them is close enough, we are going to set our target. After we set our target, we are going to play from start. We are going to lerp our current rotation, which we'll do by just this, by setting it, obviously. We're going to set our own rotation, and this rotation will be used for lerp as we move along the timeline. We're essentially doing exactly what we did here, but with just some slight changes. So we are going to do this way. Now let's test it. Let's play, and it is not working as it should. We have our alphas, we have our play from starts. We don't have our updates. This is because we did not add this node here. We need to update this, and we should also probably, if when it's finished, go back to the branch node on top. So press play. Now it is quite weird. We are not getting the proper values, and as you can see, the lights on top are in a weird direction. Let's take a look at what's happening here. We are getting actor's rotation, by which I mean self, and we are getting the location between self and B. But we are updating it every frame, which is not what we want. We want to set the rotation for our B. We can just copy this value and put it here, but recombine structure pin, put the return value here, B rotation value here, play from the start, put the value to B. Let's organize this a bit more. There are too many spaghetti codes. Return value into this. Compile, save, press play. Now, as we move around, when they are no longer close enough, they will randomize themselves. While they're close to us, by them I mean the light sources, they will start reacting. Now the issue is, like, the lights which are in the middle of randomized rotation will not go back to trigger and take a second look at us. The reason why this is happening is because the way we set up our branch node. Our branch node begins here, and our randomized lights are checking it not every second, every 8 seconds, because the way our timeline is set up. So now we have a slight issue where we need to interrupt this process in the middle and get this branch node activated to check if it is going as it should, or it should just follow. The way we can do this is we can call this another branch in the middle here. I really don't like the way this spaghetti code is looking, but we will leave it for now. Sadly, we cannot turn our timelines into functions. Now, we have this lights that is being updated every second, every frame actually. So we could, after this is done, after each update, we could recheck our branch. Let's compile and see what happens. It created an infinite loop As such, this cannot be applied. Infinite loops will instantly crash your PC. So we need to come up with a way that's not generating infinite loop. And easiest way to do it is to get a delay node at the very end here. Get it to trigger every 1 second. We could do it lower, but this should be fine. And put it in a branch. Compile, play. Because there is a delay node there, this is no longer an infinite loop, as it doesn't trigger infinitely every single second. So now we are targeted, and when we are no longer targeted, they randomize themselves. Or at least they should. Let's see what's happening. In the center of the map, it should not be able to target us. Let's see what happens. Lights are now randomized. But because we did not give them a big range for randomization, the lights move around at the last location where we walked. So they're trying to follow us, and after they finish following us, they're trying to only go in that direction. So instead, what we are going to do is we are going to edit the values in the random float range. And the way we have these values here, right? Correct. We have these random values in float range, in Y and Z axis, but what's more important is like our V axis, as this is the one responsible for, to be more clear, Y and X axis are the ones responsible for lights going out of field too much, as that's the reason why we reduce their random float range value. Now, we need to figure out a way to make sure what just happened does not happen. So what happened here was we get their actor rotation, and after we set their actor rotation, this A here became their new actor rotation. As this A is their new actor rotation, they are not resetting to their initial parameters. As such, what we can do is simply, instead of getting actor rotation every single time, or to be clear, when we are finished with this rotation, we can run a branch node again on the same branch. As I do not like this, the way this is set up, we are just going to repurpose this again. We are going to copy it, put a version of it down here. I'm going to add branch node, and we are going to test the same thing. If it is true, if it's false, and if this is finished, when the 1 second elapses when targeting the character. If this is false, as it is no longer in range, and when it is in range. If it's in range, we are just going to reset everything here on the bottom layer. And if it is false, what we are going to do is we are going to reset the rotation for our A, so it can begin from its initial point. So initial rotation for our spotlight is 0, 0, 0. We can do it exactly the same, so we can just set our rotation here at 0, 0, 0. And this should be all we need to do. As after that, we can just plug it in here. Now let's see how this will work out. We have them all trigger on us. We move around. they lose their target. And after they lose their target, they are not functioning properly. They're still pretty much very high up. And the reason is because I took the rotation of the spotlight instead of actual mesh, which what we are using. It should be -90. Always make sure to double check your values. And let's try it again. We are doing it again. The moment they lose the target, they should go back to their initial values. They should not interesting. Again, they do the same. They do properly follow the target, but they're going way too much. Oh, okay. This is another issue we have because we changed the values later on. Initially, the light range was calculated from the spotlight. Again, I have few spotlights here that I have touched and I have not restored. Always clean up after your testing to not end up in a situation like this. This is quite common, but nevertheless, it's not a good practice to not clean up. Let's restore it. And we have our mesh, which is being, sorry, the actor is which is being completely rotated. So if you look at our rotation, minus axis, this goes all the way back. We don't want it. In -90 to. So we now have, you can take a look at it as well. We have -9. The original rotation for this actor is 180. Why? It should be 0, 0. Again, this is all issues from my testing that I have not cleaned up previously. This one is more correct. So we have the same situation here. You have x-axis that goes all the way negative. We have 0 and again 0. Not sure why this keeps happening. And we have this issue here again. None of this really matters too much, as if we just simulate, we are getting a similar result to what we previously had. Now the biggest issue is when the player is not in the level. So what we can do is add an isValid node. So we have our, what we can do is we can add an isValid node. So if the target is valid, what we can do instead is, like, if the target is valid, if it is not valid, we just continue here. If it is valid, we go to branch. This is temporary, as I don't want to get the same error every single time. We're just going to check the lights again, make sure we are doing everything correctly. The lights are moving too much in certain directions. Again, the biggest issue, Z is going very high in number, while it should just remain at -90. We are going to on Control Z this. We don't need this anymore. We tested what we needed and made sure the issue was not. So instead of having these very high values, we are going to have minimum of -90 and maximum of -60. Right, let's see what happens now. They're moving very close to the range. So instead, let's do it a bit more. Let's do positive 45. Press play. We could also just take the middle ground and make it 45 to -45, which will randomize it in all directions equally. Which is fine. Now let's play this again, see how it works. And after the moment they lose the directionality, they should go back to how they should function previously. So let's see what's going on here. We have our strategy. So the moment this is finished, we check it. If we are beyond the range of 2000, as when this is false, let's simulate this and take a look at what's happening here. Let's select this light, which is number 28. Let's expand this and press play. And for our debug actor, select 26. What's happening now? This is just repeating itself, setting its own rotation after it's finished, and the delay is created. Oh, okay, this is the issue. We never reach the finish node, as this is always going all the way back and creating this issue where this is always constantly playing. Okay. As such, what we need to do is we need to do this delay actually happens. Sorry, the execution pin of this delay doesn't go all the way back and just goes the correct place. So what we can do is, okay, so we have this. When it is finished, we have this delay, and when we have this, we get set actor rotation. And we need to, after this all is finished, check the branch node. Instead of straight up forwarding it all the way back, what we can do is we can just add this branch node again. And before we move on, let's properly organize all these nodes. The only way, what we need to do is we need to get this value and make it a variable so that we don't have to do all of this again every single time. So what we can do is we can get this into a variable, make it into a variable, and we need to set this variable. Oh, not all of this. By turning all of this into a function, we will collapse it to function, call it distance to player. Distance to player. And when we do need this, we need it is before this branch. And every time we need this, we can just put in this function instead of having this spaghetti of a code that's just inefficient. So what we'll do, distance to player, drag it, drop in, and we do it again here, distance to player. This will just check the distance to player. If it is so the way let's look at it. If the distance to player is less than 2000 units, less than 2000, we set this value and we return this node. So here, if the distance is less than 2000 units, all of this happens as it did previously. And here, after this is updated, second passes, the delay happens. And after the delay, we get the distance to the player. If the distance to the player currently, after this 1 second of delay during the update of this timeline, is less than 2000, we go all the way back and recheck, or we don't even have to check, we straight up go to branch, as we already have set up already. Checks the distance to the player, and we go, if it's false, nothing happens. And all of this just keeps functioning until this is finished. So now let's try it now again. And let's see. Zoom out. And press play. This happens. This is checked. We wait until it's finished, which will be 8 seconds. After 8 seconds, it's finished and restarts itself. Perfect. You might notice if you test it that your lights will not work properly. And this is the reason. The way these functions work, they only produce this value when they are actually triggered. And when we have the true here and we go all the way back, if we don't recheck the value of the distance to player, this function will not work properly. And what we need to do is we make sure we only have all nodes that come to this should actually come to here. And we should make sure before branch triggers, we trigger the distance to player event. This way, we will be able to make sure the value, which is true or false, from the distance to player function is actually accurate. So we are going to compile, play, and go back to the level, and let's see how it works. And after they cannot find us, they go back to their random rotations, and when we go close, they notice us and they start following us around. Now, obviously, we could tweak it around to make lights more accurate. Maybe you want to limit their range further, etc. But we're going to keep it like this for now, as we are going to change the lights functionality depending on the gameplay as well. This will not be actually this randomized constantly, because surrounding lights will focus on the objectives if the objectives are nearby. Before we move on to actually start implementing gameplay elements, let's modify our light once more. We have lights that move around the level, and we have them go outside the level. The reason why this is happening is because we give them randomized numbers. As such, they don't really have any point in the map they are trying to focus on. It's an easy fix, especially what we have already implemented. You can stop the simulation. And we could give them a value and modify that value by this random value to make sure we get them in a certain area, all lights focused in a certain area. What we can also do, we can use our already established target here, get target, and use this as a placeholder for the light to focus on. So we have this logic already here that we previously created. Let's take this and apply it here. Now we have this final look at rotation, and we have this random floats that gives randomness to this rotation value that's being set here. What we can do is we can combine these two rotators, which will give us a value that's not completely random. Now let's combine rotators A and B, and we pitch in this combined return value into B. Now let's take a look at our level. There's still some randomness in the level, but they are going to all try to focus on the light. Sorry, on the target. And when the target is moving around, they move with it. Obviously, we don't want this cube to be the target. As such, what we can do is, this is still center of the level, more or less, and we can force down this value. And what we can do is we can copy this location, go back to BP light, remove get actor location from the target, and split this struct bin. And let's take a look at our values here. X, Y, and Z. Compile, press play. They will behave in a similar fashion, but they are no longer targeting this specific cube. They are now just rotating in the general direction around where this cube was initially located. You could also target the level itself, or you can also just make this cube invisible, put it down, and call it a day, but there is no reason to overly complicate when you can hard code the values you want. We could do it in multiple ways, but this just works. Now let's organize our code so we have easier time for the next time we actually need these. Let's convert some of the things here into functions. We cannot add timeline to functions, so let's do this. Convert to function, collapsed function specifically. Let's call it rotation generation / random. This is here just to keep everything organized. And I will rename this function properly. Make sure to test your blueprints always. And if it works as it should, you can just continue on. Yes, most of the lights are directed inwards. We can also reduce the values of randomness so it doesn't go too far beyond what we want. And this should be reasonable enough. Let's make it 20 to 20. While random numbers are fine, having them being going too far upwards is not ideal. And now we have this disco-like effect. We ignore the error, it's because the player is not actually in the level. We can add an isValid node, but that will not be actually necessary when we are done with this. So let's take this as well. And this time what we are going to do, we're going to collapse this into a function as well, but it's a different function, as it's a function that's looking at the player. And we are going to select them all, collapse the function, found player rotation. Just going to name it that way. Everything is fine. We can go back to event graph, see if we need to organize anything else. Comment sections are now too big, so let's reduce them. Let's see, we cannot put this timeline into the function as it's a time-related event, and there is no real reason to collapse these two nodes into function, as we are not going to really reuse them too much. We have them in a certain manner here, but they are not really an efficient way of us to put into a function. This can remain as it is. Delays cannot be added into function or macros. And now we have a slightly more clear. We still have this node going all the way, but it's fine. We could probably make it look better if we reorganize more, but I don't want to waste too much time here. We have our color settings here, and next we are going to edit them when we actually implement gameplay elements. So